Now, the third method of tuning, Ziegler-Nichols method number 2. For this, you put it in auto. So this is an auto-tuning method. So you stick the loop in auto. You've got the P term, the I term, and the D term. You stick 3 boxes. You stick a 0 in the P, you stick a 0 in the I, and you stick a 0 in the D. And then you start increasing the P. You increase the P, and you increase the P, and you increase the P until you get stacks of oscillation. So you get a nice sustained oscillation. Sustained oscillation is oscillation that's there to stay. It's not what's called decaying oscillation, and it's not what's called increasing oscillation. It's sustained oscillation. It's oscillation which is just ticking along nicely. So you keep increasing this until you get to sustained oscillation. And when you've got to sustained oscillation, you sit and watch it oscillating. Oops. And basically, while it's oscillating, you work out the period of the oscillation. So you just time it with a stopwatch, or you look at a graph. So I'll just pull that graph up there. Here's a graph of the thing oscillating. The mauve line at the top, there's the valve. This is the process variable, which might be a flow or a level. Right, what we do is, we find 2 things. KCU, which is called the ultimate gain, that's the value that we had in the P when it started to oscillate. Oh, that's not good. So KCU is the P value at oscillation. So if you had 10 in there, then your KCU is 10. The PU, that's simply the time period of the oscillation. Now, once again, I have to emphasize that you are not allowed to oscillate. You're not allowed to oscillate a real system. So you're not actually allowed to do this in the field. The reason I'm teaching you how to do it, well, next time I'll tell you why, when you've had a little bit of a chance to have a practice at some of this stuff. So, you have these 2 things, the P value when it was oscillating, and the gain of the oscillation. Now, we go to a table. It's a different table from last time. What should we use? Should we use pure proportional control? Should we use P and I control? Or should we use P and I and D control? What would you choose to use? Okay, 99.99% of the time, we're just going to use PI control. So we're only going to use P control when we've got something which is completely predictable. We'll use PI when we have something which is not totally predictable. This time we're using feedback, so we're not going to want to use pure P. And we don't want to use D because we don't like using D. In this case, the P value is got from this equation here. That's the P value. The I value is got from this equation here. That's the I value. So, quick example. If I had this nice and oscillating, and my gain at time of oscillation, P equals 10. So So I had a p-value of 10, and it was oscillating like a beauty, and the time interval was 20. So the time period of the oscillation was 20. Time period of the oscillation was 20. Then this is the open loop values. This is the KCU. So that gives me a KCU of 10. What's the other thing called? A PU. A PU of 20. And from the equations, I calculated my new p-value is 0.45 times KCU, which is a nice little number. It's 4.5, about half actually. Me, I'd just normally halve it. I equals PU over 1.2 equals 20 over 1.2 equals, grab my calculator, 17. Okay, so they're the values I would stick in. It's a lovely method. It gives you good values on the whole, but you're not allowed to use it. Shame, really. So they're the three methods of tuning. Trial and error, open loop bump, which is the one we should use in the field, and sustained oscillation.